Hey, Chemsters, this is Mrs. Vandelay bringing you some more Lewis dot structure stuff, but actually we're not doing true Lewis dot structures. I'm going to show you how real organic chemists do organic line notation, okay? And so this is really a nice shorthand way of doing what we just did. Now, why do we learn this? Well, let me show you, okay? So look at the first part. Place the correct number of hydrogens off the carbons and lone pairs of oxygen or nitrogen if needed on the following molecules. Keep in mind the total number of valence electrons needed. Well, let's, before we begin, remember something. Carbon must always have a total of 4 bonds. What does that also mean? Carbon will have no lone pairs. Nitrogen must have 3 bonds or 1 lone pair. Oxygen must have 2 bonds or 2 lone pairs, and that's going to help tremendously. Okay, so let's look at the first one. Well, each carbon must have what? 4 bonds and no lone pairs. So how many hydrogens are here? Well, I need to have 1, 2, 2, and 3. Why 3? Because how many bonds does this carbon now have? 1, 2, 3, 4. Well, how many bonds does this carbon have right now? It has 2. So how many hydrogens do I need? It needs 2. 1, 2. How many hydrogens does this carbon need? 2. 1, 2. Do you see where I'm going with this? This already has 2 bonds. So how many hydrogens does that carbon want? 2. 1, 2. Whoops. There we go. And how many bonds does this carbon have? It has only 1 bond, so it needs 3 hydrogens for a total of 4 bonds and no lone pairs. So this would be a structural formula. Did you catch that? That would be, in a sense, a structural formula where I can see the actual structure and the actual bonds. If I were to just, put this all together, I have 1, 2, 3, 4, 5 carbons, and count up all your hydrogens. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is my molecular formula, okay? Let's try the next one. It's a little bit different, isn't it? So how many bonds does this carbon have? It has only 1. So I will, I will put this here. And then it needs another hydrogen and another hydrogen. Why? So that carbon has, everyone, 4 bonds. 1, 2, 3, 4. How many bonds does this carbon right now has? It has 2. So how many hydrogens does it need? 1, 2. Remember, carbon only has 4 lone pairs, or excuse me, 4 bonds and 0 lone pairs. So how many does this one need? It needs 2 more hydrogens. I'm getting there. 1, 2. And how many does this one need? I think it also needs 2. 1, 2. But I'm not done yet. What do I do about oxygen? It says place the correct number of hydrogens off the carbons, which I've done, and lone pairs of oxygen or nitrogen. So how many bonds does this oxygen have? It has 1 bond and 2 bonds. So if it's 2 bonds, it needs what? 2 lone pairs. So you need to put in 1 lone pair and 2 lone pairs. Now, if you truly want to, you can go ahead and count up how many valence electrons this all has. All right, how many electrons are in by bonding? I guess you're going to come up with 4 shy, and those are your lone pairs, okay? So that would be a structural formula. What's the molecular formula? Well, I have 4 carbons. Here I have 9 hydrogens, 1 O, 1 H. Now, I could, do it this way, or I could do it this way. When you read it like this, it's kind of like a structural formula. What does it tell you more than this? It tells you that the placement of the oxygen has a hydrogen with it. Here, it doesn't necessarily mean there's a hydrogen with it. So it kind of tells me there's an OH together. With this one, I can't really see it. I'd have to draw it all out, count all my electrons, and see where everything goes, okay? So this to me is a little bit more informative than this. This is a molecular formula. It tells me it's 4 carbons, 10 hydrogens, and 1 oxygen, but it really doesn't tell me how they're all put together. All right, so what I'd like you to do is do the same thing here. go ahead and draw all the H's and all the lone pairs here and come up with the molecular formulas, okay? So pause this, I mean it, and come back when you're done. All right, so this is what I did. And I put 3 hydrogens around each carbon on the first one, and don't forget, you put your lone pairs on the oxygen. Now, why didn't I put anything on this carbon? Well, it already has 4 bonds. 1, 2, 3, 4. 4 is the magic number for carbon. So if it already has 4 bonds, don't put any more hydrogens on there, okay? And this is the molecular formula. It has 3 carbons, 6 hydrogens, and 1 oxygen, okay? This is not a really good indication of where I know the oxygen is. Actually, there could be several different places where that oxygen could be. So what would be a better formula for that? Well, let me show you. All right, this would be maybe a little bit better. So I have CH3 right here, then I have a CO, and I have a CH3. That kind of tells me that the O is like in the middle, okay? And then finally, this is what I did. Don't forget your lone pairs. And I have C5H11. That's this string right here. So C5H11. All right. And then notice I have a COOH. So I know the last carbon has OOH on it. Do you remember what I told you? If you ever see OO together, you have a double bond and a single bond. We did that in the last video. So to me, this is a much more informative formula. It tells me I have that COOH going. Here, this just tells me I have 6 carbons, 12 hydrogens, and 2 oxygens. Doesn't tell me a whole lot. So would you like to have to write out H's like that all the time? And the answer is no way, Jose. In organic, you write carbons all the time. You write hydrocarbons all the time. And that gets really monotonous, let me tell you. So they have come up with maybe a little bit easier way of representing the same stuff. So I'm looking down here. Let me scroll down. And this is a line notation, okay? So you use zigzags, and you zigzag your way through, and you show at each apex. Ooh, that's a good word for math class. That's where like the two vectors intersect, all right? So where the 2 lines come together, that's a carbon. All right, at the end is a carbon, and they will be a carbon unless they're otherwise noted, okay? So notice when you do line notation, you have no reason to write the hydrogens. We all can count to 4, can't we? So the question is, how many hydrogens do I know in my heart of hearts on this carbon? Well, it only has 1 bond that has to have 3 hydrogens. How many hydrogens are here? Well, how many bonds does this carbon already have? 1, 2, 3. It has 1 hydrogen. This has 1 hydrogen. This has 1 hydrogen. This has 1 hydrogen, and this has how many? 3. So 3, 4, 5, 6, 7, 10. So that formula is C6H10. And I don't have to put the hydrogens in. All right, I know if they are carbons, I know how many hydrogens they're going to be. I will have to notate if there's something besides a hydrogen. So what would this one be? How many hydrogens are here? 3. Now look closely. How many are on this one? I already have 1, 2, 3, 4 bonds. I don't need another hydrogen. There's no hydrogens here and no hydrogens here. So I have 2 and 3, and that makes what? C5H8. So look at the next ones. Oh, looky here. There is an oxygen here. Do you remember what we said about oxygen? It needs 2 bonds and 2 lone pairs. So are there any hydrogens off of this one? No, it already has a double bond. It doesn't need any more bonds. It needs 2 lone pairs. So this has how many hydrogens? 3. How many hydrogens? 2. How many hydrogens here? None. Why not? It has 1, 2, 3, 4 bonds already. It doesn't need another bond. So there's no hydrogens here. And how many in this one? 3. So put it together and it looks like that. C4H8O. Again, it doesn't really tell me where the O is. I could fix it around, but let's not do that right now. So let's look at this one. How many hydrogens are here? 3. How many hydrogens are here? 2. How many hydrogens are here? None. How many hydrogens are here? None, it already has its 2 bonds. Now look at nitrogen. What did we say at the tippy top of this paper? Nitrogen has to have 1 lone pair. If it has 1 lone pair, it has to have 3 bonds. So let's go down here. How many bonds does this have right now? 1. So how many hydrogens does it need to have 3 bonds? It needs 2 more. So here is this. This is kind of a structural formula. If you wanted to write it something like this one, it'd be like C3H7N. All right, but again, if you can kind of clue me in where all these things are, that's usually better. So why don't you try these guys, all right, and pause this and we're done, come back. Okie dokies, this is what I did. All right, so this is my structural formula. Notice I put the COO together because I know if I see COO, one's a double bond, one's a single bond. All right, so here's my C3H7. Here's my C2H5. All right, this carbon doesn't have any hydrogens. It has double bond O and another O. Here, oh, by the way, I could also do this. Okay, I could put them all together. And I get C6H12O2. Again, that doesn't really tell me where the O's are. They could be in a couple different spots, but that's another way of doing it, just the molecular. Now here, C6H6, every single carbon already has 3 bonds, so there's only 1 more hydrogen left, okay? So what I'd like to do, all right, now you don't need another page, all right, but hopefully you can do it. Here's the same page. But what I want to do now is actually go through and do the best line notation, okay? So here I have 5 carbons. So how would I actually do that? You're going to be making some lines, all right? What color? Do you want to make them red? Let's make them red. Ready? So I have 1 carbon here, 1, 2 carbons. Oops. Shoot. Hang on. This worked earlier. All right, and then here's another set of carbons. Well, I promise you it worked earlier when I tried it out. And then here's another one, and maybe I don't click on it. Sorry, guys. And then here's another one. So I have 1, 2, 3, 4, 5. So just writing, let's say that zigzag M tells me it's C5H what? Well, 3 plus 2 plus 2 plus 2 plus 3 is 12. So that's a C5H12. So how would I do something like this next one? All right, let's see if I can't do it better. All right, either that or I give up. Okay, so I'm not going to give up. What am I saying? So I have 4 carbons. 1, 2, there we go. 3. Okay, I have 1, 2, 3, 4 carbons. But now I have an O. All right, what do I do with that? I have to write it down. So I'm going to do something like that, and I'm going to leave it. That would be the best line notation for this molecule. Why? I see I have 4 carbons, and if I don't write anything else, I know they're all hydrogens. Now look at the O. Why didn't I write OH? Because how many bonds must oxygen have? 2. How many lone pairs does oxygen have? 2. Well, right now is 1 bond, so I need another bond, and if I don't write it down, it's going to be an H. Okay, let's try this next one. All right, so what about here? I guess I'll leave it in the black. So I have 3 carbons, 1, 2, 3. So notice I have 1, 2, 3 carbons, but now what? What is off of that middle carbon? It's my oxygen. So that would be how you draw that line notation. You don't have to write any elements except for the O. So what about this next one over here? What am I going to have to do with that? All right, well, all right, let me try this one. All right, let's try it again. So I'm going to have 1, 2, 3, 4, 5, 6. Ready? So 1, 2, shoot. 3, 4, 5, 6. Let me track. 1, 2, 3, 4, 5, 6. Now this is this carbon right here. All right, what's on that carbon? I have a double bond O, so I'll do that, And what else do I have? I have a single bond O. All right, and that would be the line notation for this. All right, so once again, you make a zigzag. Every time there's a zigzag, you have a carbon. 1, 2, 3, 4, 5, 6. And anything that's not a carbon or a hydrogen, you do have to write down, okay? Now here, I started, I guess, easing you into this line notation, but what's different? Do I have to put all these carbons in here? And the answer is no. So how am I going to do this? All right, so I'm going to kind of follow along. 1, 2, 3, 4, 5, 6, right? But what else is different? That's a single bond. This is a double bond. So you got to do something like that and do something like that. And now you're totally done. You don't have to do anything else. All right, and what about the next one? We have 1, 2, 3, there we go. So I have 1, 2, 3, 4, 5, but this here is a triple bond. So you do something like that, and now you're done. All right, now I've also seen this triple bond done something like this. Watch. And then I can do something like this, and then something like this. All right, how many carbons are represented in this structure? 1, 2, 3, 4, and now you have one more carbon. We can do something like that if you want. So this shows me I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Why would someone even think about drawing that structure like this? Because guess what? Whenever you have a triple bond, it is linear. All right, those 4 carbons, believe it or not, are actually in a line, and this shows it better than this, okay? So you might see the triple bond either way. Now, I don't think this is wrong. I don't think the colleges will mind you doing this because it's easier to see, oh, you do have 4 carbons there, and here's your 5th carbon, okay? So what I'd like you to do now is to actually do these next couple without any like carbons, all right? You still have to put the oxygens in, but redraw them without the carbons, all right? Go ahead and do that. Take a pause and actually finish this whole page. All right, so this is what I came up with. How about you? This is a lot easier when I've already done most of the work for you. But I do want to show you this, okay? This is perfectly fine, and as is this. Now, what's the difference? If I had put something like this, well, if I had put this here, that would be wrong, because then this end would be a carbon. Then I'd have 4 carbons. I don't want that. So this works out great, but if you don't put like a little bond, you just end it, that's fine as well. Often, if you do it this way, you make this line shorter than you would have with the carbon, all right? So it really kind of depends on what your college professor does, is, you know, what you ought to be careful of. So I've seen it truly both ways. I would probably do it more like this, all right, if I had to do it. Down below, here's this one. Again, if it's not a carbon, you do have to put the O in. So that's why here that's an O. I actually had to put that back in again. And this is done exactly the same. So that is line notation. And if you start drawing your organic molecules using line notation, I bet on the first day of organic chemistry, boy, your professor will be impressed with you, all right, because not a lot of people know about that, okay? So there you go. Don't wait to be great. We'll see you next time. Take care. Bye-bye.